Chapter 6 is looking at a different distribution we had before. It's not the normal curve, it's going to be called the chi-square distribution. Chi-square distribution is always going to be a right-tail test, and there's a little picture of it showing you the symbol of chi-square and the area of our p-value, our probability. It's going to be from that test statistic over to the right. It's a skewed distribution. It's not going to be normal. Now, we're not going to get into too much of the details of why this happens. We're looking at completely different things. We're not looking at averages. We're not looking at proportions. We're going to be looking at counts. Okay? And what we're going to do is be measuring those counts and seeing where do the counts fall and if they are even throughout the sample that we have. There are three different types of hypothesis tests that we're going to use. And in this video, basically what I'm going to go through are the three tests of probably the details of how you're going to decide what test you're going to use, and the null and alternate. The null and alternate is going to be a little different. It's not going to be a expression like equal to or inequality less than, greater than, not equal to. It's going to be a sentence, a statement about the population. So the first one is the goodness of fit test. How well does the population fit the assumed distribution? This is going to be one variable with one sample. The test of homogeneity, this is going to be looking at multiple samples. Now, it's not going to be organized as a table, but the way these samples are going to be taken is very important. The number 2 test of homogeneity and the test of independence, these are going to be very closely related, the way the test is run. Each one of these, the null and alternate, are going to be worded slightly different, and that's going to be the important thing, because the calculations aren't going to be very different, but the null and alternate is going to be different. So that's what you're going to have to do. And of course, the null and alternate is the first thing you need to pick out. So what we're going to do is go through a couple examples so you can see the wording, because this again is something where everyone's null and alternate, even though it's going to be a sentence, kind of a way of a free response, everyone's null and alternate should be extremely similar when you're writing them out. Okay, so for the goodness of fit test, okay, does the population fit the assumed distribution? It's one variable and you're looking at the counts. Okay, there's going to be one variable that we're looking at with the sample. We look at it and we're going to be looking at where do the counts fall in those situations, in this situation. Now there's two different things that could happen in a goodness of fit test. Okay, the first example here is color blindness. And the important phrase here that we're looking at color blindness, and if you are colorblind, normal eyesight non-carrier, normal eyesight carrier. And the important statement here is right here. It is said that you have an equal chance to fall into any of the three categories. Equal chance here is important. What they're saying is this count should be similar for each one of the categories. Now you might be able to see, obviously you can see maybe the color blindness is the one that's on be off. It's the furthest away from the other two, or the lowest one. Also, you can see the normal non-carrier is the highest. So there's a pretty big difference there between the lowest and the highest. But we have to run the test to make sure. Now, the null and alternate is going to have to do with that equal chance. The null, the distribution of having color blindness or being a carrier, is uniformed. Uniform means similar. It's going to be equal all the way across. So it is that equal, just like we had before. But now instead of writing colorblind equals normal, non-carrier equals normal carrier, we're just writing as a sentence and telling us that it is uniformed. The alternative here, the distribution of having color blindness or being a carrier, is not uniform, which just means at least one. And I'm going to say it again, at least one. That's important there. At least one of those categories is not going to be similar to the other ones. And that's what we're going to be testing. Is there a difference in one of the categories? Now, for this example, it said equal chance for each one of the categories. The other example that we have in this chapter is looking at household types. Now this time, we're looking at the U.S. Census and the type of households, and below is a table of what the percents are predicted to be for a small community. So it's not saying that every household type is equally distributed throughout the population. There is some unbalance here. These percentages here are our predictions. We think married with children is on be 26%. Singled is only 9%. So they're not all the way down with 5 categories, it would be 20% all the way down. Each category is different. It adds up to 100 still, but it's going to be different. So you can't use the term uniform in your null and alternate. Okay? For our null this time, the population fits the predicted distribution for household types. You don't need to list every single percentage. You can. Okay? You can have the proportion for married couples is married with children is 26%. Married without children is 29%. You could go all the way down. Just sometimes there's going to be some fairly big lists. You're not going to want to do that. So we write it as a statement. The population fits the predicted distribution for household types. The alternative, again, is just saying that it does not fit the distribution. The population does not fit the predicted distribution for household types. And what it's saying is that at least one of those categories does not fit. At least one of those percentages does not match what we are predicting it's going to be. Okay, so that is for the goodness of fit test. And there's 2 situations. They're both a single list of counts for our observed, and it's looking at one variable. This was looking at types of households. This was looking at color blindness. So it was one variable, and we just had one list of counts. For the other 2, test of homogeneity and for the independence test, these are both going to be set up as tables. Okay, so there's going to be 2 variables we're going to look at. Now it's important to tell which test you're running because the null and alternate will be slightly different. Okay, so what we're looking at first is going to be the test of homogeneity, and that is looking at different samples, multiple samples. And that's important just because you're going to be, when you take your individuals to be a part of your study, you know what you're looking for. You're not just randomly selecting people. You are selecting people from certain subgroups. So for this one, we are testing multiple portions with multiple samples. And the example here is looking at, this is something we looked at a long time ago, the political viewpoint compared to their thoughts on spending on the environment. So we had liberal, moderate, and conservative. Now for this one, okay, we are looking at the 3 political viewpoints. And in this case, since it is, I would be selecting each one of these. Okay, I'm going to take a sample of liberals, a sample of moderates, a sample of conservatives. So since I know that, this would be considered homogeneity because we are specifically taking samples of each of those. Okay, we're not taking one sample then asking for their viewpoint and then their political viewpoint and their viewpoint on environmental spending. This one, I'm going to tell you right now that we took a sample of liberals, a sample of moderates, and then a sample of conservatives. For the null and alternate in this case, the viewpoint of federal spending by the government on the environment has the same distribution for the different political groups. Meaning, it's not saying that too little, about right, and too much are all equal for each one, but we're saying that too little has the same proportion for all 3 groups. Too much is the same distribution for all 3 groups. Okay, that's not that it's equal all the way down, but it's equal going across. Those proportions are equal. And just like before, the alternative is just saying that it does not fit that distribution. The same viewpoint on federal spending by the government on the environments do not have the same distributions for the different political groups. Okay? So it's just saying at least one of these groups, the percentages are going to be a little different. The counts do not fall evenly across, going across each one of our categories for the environment viewpoints. For the test of independence, this is looking at one sample and 2 variables, but we're taking just the sample and then asking or looking at those 2 variables. So it's going to be a random sample of individuals, and you then look for the 2 variables. So it's almost like the retrospective and prospective studies that we talked about for observation. Okay, for one, you know one of the variables. You are going to select people for those samples and then look at just one other variable. For the independent group, we are just selecting individuals, and after they are selected, then we look at the 2 variables. So here we are looking at gender and being admitted to college. Okay, so we have our male, female, and then being admitted or denied into the college program. For this one, Your gender and being accepted into college are independent. Your gender and being accepted into college are not independent. Please stay away from using the term dependent. Okay? I know not independent it makes you think it has to be dependent then, but we're not testing that. We're just testing to see if they are not independent. And again, I know that sounds strange, but please try and stay away from the term dependent. Another way you could phrase these ones, I'm saying your gender and being accepted into college are independent. You could talk about in relationship. There is no relationship between gender and being accepted into college. There is a relationship between gender and being accepted into college. And just saying that there is a relationship doesn't mean that they're dependent on each other. It just means that somehow there is a connection, but it doesn't mean your gender is causing if you were admitted into college or not. Okay, so you can't have that cause and effect right now, okay, but we can say there is a relationship. Okay, so there's a look at the null and alternate for the three situations. The next couple of videos will show you how to run the test and the calculator functions.